Welcome to the Cycle World podcast. We're in with another episode. It's Kevin Cameron, our technical editor, and I'm Mark Hoyer, the editor-in-chief. The podcast is brought to you by Octane Lending. We've got to get the sponsor in because they make it all possible. There's a link to Prequalified, it's called, in our description. Go click that link. If you're shopping for a bike, click the link and check in on being pre-qualified and being able to go to the dealer, same as cash, and negotiating with that dealer. So see if you can get pre-approved or just go check it out. It helps us a ton if you click the link. Thank you again, Octane. This week's topic is the Moto Guzzi 500cc V-8 of the 1950s. I have not stood next to the real one. I stood next to a replica, a very thorough and complete replica, beautiful bike. It 8 20mm Delorto carburetors, tiny little Delorto carburetors on the original 500 V8, double overhead cam, liquid cooled, spun to 14,000 RPM at the end, making nearly 80 horsepower. Top speeding in the 180 mile an hour range. Just a magnificent, wonderful, complex, constantly evolved race bike of the 1950s at a time when, Guzzi was doing well with its laydown single. Chain
which were
drive.
so light and handy and had raw torque. So they were like a piece of paper being rushed around the circuit by a quite moderate engine.
So anyway, let's talk about this thing. Kevin, you've done a lot of reading on this subject over decades, I would imagine.
Who could resist?
Yeah.
Well, the thing to realize first is how much Guzzi accomplished with its horizontal single-cylinder engines. They just kept making them lighter, and they never lost track of the fact that they had to accelerate. They didn't build for top speed. They built for wide-range acceleration so that while four-cylinder bikes or DKW's two-stroke triple were revving their guts out, the single was just chugging off those corners like crazy. So then they built this inline four with the engine crankshaft longitudinal, like an old FN single or a Henderson. And the engine looked like a miniature Offenhauser. It was a beautiful little four-cylinder double overhead cam engine. And they tried it out in 53 and 54, and it just was not what the doctor ordered. So chief engineer Giulio Cesare Carcano looked at the competition, which was originally Gilera and then MV added in 1950. And he thought, we're not going to build a four because those two companies have a big head start in that area. We're not going to build a six because it's going to be quite wide. Mind you, this is going to be a 500. So that meant it had to be a V8. It would be, the crankshaft width would be something like 13 and a half inches.
Amazing.
With bearings and accessories outboard of that. And the cylinder dimensions were 44 by 41. Anyone who's read up on Honda's very successful early four-cylinder 250s knows those dimensions, 44 by 41, because that's what Honda ended up with as well. The crankcases and the covers were made of magnesium, and the typical wall thickness of material was 4 millimeters, which is like 3/16 of an inch. So good quality casting techniques. And They started out with a crankshaft made in one piece with hardened journals, with split rods and split main bearings assembled over it. And then the crankcase was open on both ends so you could slide the crankshaft in, lift it up to the center three main bearings, and do up the caps, and then the outer main bearings were on the outer covers. They decided, or I should, well, Carcano, Enrico Cantoni, and the man that built those lovely Guzzi V twins, Dr. Whitner, knew so well during his time at Moto Guzzi, Umberto Todaro. And those three men were the designers of the V8. They chose to avoid the whole question of head gaskets by screwing the cylinder liners into the heads. There were two heads. The liners screwed in. When the cylinder heads with the cylinders attached were removed, you could see the entire water jacket, whether it was accumulating crud or not. And the valve angle was a surprisingly modern 58 degrees. Well, not surprising for Guzzi, they'd been using 58 degrees since the 1930s. While everyone else in Italy was using at least 90 degrees, the valves were widely splayed apart on MV and on Geleras.
And for cooling, right?
Yep.
Opening up the top of the head for cooling, and also
Sure. Yeah.
they were using they're really sticking the flow to the chamber and bringing it in and swirling it around as
Yep.
the Hemi folks did for a very long time.
And the strange part about this whole program is that it was so small. Because today we think of, for example, Ducati showing up at superbike races in the 90s, late 90s, with boxes and boxes of engines fresh off the dyno in the truck, ready to go. That was not the case. When Bill Lomas, kind of a combination engineer and actually competitive rider, had his go at the V8, I'm getting ahead of myself here. Anyway, back to the engine. They gave it 4 speeds initially. It would later have a greater number of speeds, but for a lot of racetracks, they found it was quicker to have just 4 speeds because there would be less shifting time. And initially, the engine was made to run at 12,000 RPM, and it made horsepower that was competitive with the existing 4s. But then they decided that they weren't getting anywhere with the split bearings. Split bearings and split rods, split and bolted. So they switched to a pressed together crankshaft. And the difficulty there, they started out with a 180-degree crankshaft, and they broke the studs supporting the center 3 main bearings. So they decided to switch to a 90-degree crank pin arrangement so that they could take some load off of those studs. With the pressed together crankshaft, the engine could run to 12,000 RPM. And they were able to get quite a lot of testing done. I know what I was going to speak of a moment ago, which was that Lomas, when he came on the scene, said they had 2 bikes and another engine. That's not enough. But they had approximately an 11-man race team, and they were making all these parts themselves. They even made the carburetors to Del Oro's design, tiny little 20 millimeters at first, and later on in 57, 22 millimeters. So Lomas was not a popular man wherever he went, because he would say, "Oh, incidentally, I think you might do this to your advantage." And he would show that the lap times were better, but the design team wanted to justify their paychecks, so they just kept it theirs. And so there was always a lot of tension. There was a tension field around Lomas. And anyway, the engine, they couldn't get somebody to make them a magneto that would produce 800 sparks per second. So they went with a coil and battery system, and on each cylinder head was a camshaft driven, rather large contact breaker housing, each one containing 4 contact breakers, one for each
Amazing.
cylinder
So
in the bank.
this goes into setup and tuning, what we used to have to do all the time, and setting up 4 contact breakers and making sure that the lobes are perfect so that the spark timing is perfect.
Yep.
I mean, it's a machining operation, and they're running them off the end of the cams, which
Yep.
is fine because the cams aren't that long. But if you get a long cam, you would get some torsional vibration potentially
Yes,
that
indeed.
might scatter your
Also,
spark. We don't even know what spark scatter is anymore. And a coil per cylinder, I love that. That's so modern.
yes, because today we have them integrated with the plug cap. So it spends its life down in a deep hole in the center of the cylinder head, and no one ever sees it, or the spark plug.
Don't even think of it. Yeah.
No. So, like the current Ducati Moto GP engines, the V8 had thin, delicate, drilled for lightness cam drive gears on one end of the crankshaft. And they made that characteristic Mickey Mouse ears shape.
Such a beautiful view on
It
that
is.
side.
It's just lovely.
It suggests so much.
And this is why I've always liked shrink wrapped looking castings that reveal the nature of what is there.
I'm going to go on record and disappoint the producer right now of our podcast and say that we're stand by for photos. We're going to run some pictures of this V8 in this podcast because it's totally worth it. This is gorgeous. Yeah.
The gearbox and clutch were quite conventional. It had a drum selection and a multi-plate dry clutch, quite large in diameter.
Our Italian contributor for Cycle World in the early 1960s, Carlo Pirelli, had said, yes, they did indeed try 4, 5, and 6 speeds. And in his words, the 6-speed was useless because it slowed the bike down. The bike had plenty of torque. It was really noted for its torque, as you had said about the other Moto Guzzis developing torque. Yeah. Now you have a V8, and that was one of the key characteristics of the power plant.
Well, Bill Lomas said that it pulled from 7.
And which is where the Manxes were signing off.
Yes.
And had higher, a Manx at 7,000 RPM would have a higher piston speed than the Guzzi V8 at 14.
Yeah. So this is a 5,000 RPM torque band. Now, if you look at superbikes, you will see typically 1,500 RPM. And that is to work with the 6-speed. All modern motorcycles pretty much have 6 speeds. And so this engine shared the characteristic of the 4-cylinder racers, the 4-cylinder 500s, of which it was said, and I think of the Gilera, that on occasion, one of the mechanics would start one and ride down to the smoke shop for cigarettes because they were very tractable. They weren't high RPM screamers with an inch-wide power band. So there's also a picture in Bill Lomas's book, which I recommend, showing him holding the V8, standing up, holding it up. Doesn't look like he's under any strain.
Oh,
They
magnesium.
claim
I mean,
the
it's
total weight was under 300 pounds for the bicycle. Well, problem is the other manufacturers had put in 4 or 5 years to make their bikes deal with the Nortons with their wonderful new twin loop chassis and hydraulic damped suspension. And as it turns out, Guzzi didn't have that long. So the list of failures, they had big end failures, they had tappets coming loose, they had overheating, a water pump stopped working. These are all things which are taken care of by the test team. Moto Guzzi didn't have a test team. That kind of structure was just too big for companies making motorcycles in those days. And this is something that the Japanese manufacturers, with their large volumes, were able to bring to motorcycle sport that had never been there before. Well, leaving out NSU and DKW, both of whom had monster race teams in the 50s. So the engine was a wonderful, ambitious thing. Let's just believe that if we leap off of this cliff into empty space, that we will reach safety and everything will be well. And they came close to making the thing reliable. They got 2 of them to finish the TT. Not very high up. I think one of them was 4th. So that would imply some limitation of performance in the interest of finishing the race. By that time, they were using a German-made Hirth crankshaft. Hirth had also made the roller crankshafts for Mercedes-Benz 600 horsepower racers, W125 before the war. This type of crankshaft was assembled out of many sections joined together by radial face splines. You would press the end of one crank pin against the corresponding spline on the face of an adjacent flywheel, and inside, a differential threaded bolt would draw them together under tremendous pressure. So why did they go to the Hirth crankshaft, which was quite expensive? And why did they only order 2? Because the pressed together crankshaft was sort of iffy at 12,000. And Lomas, who had ridden the motorcycle quite a bit and who had an analytical engineering mind, he grew up in a household where his dad worked for Rolls-Royce. He knew that as the tack needle flew up to 12,000, that it wasn't slowing down. And so as far as he was concerned, there was another 2,000 RPM of good performance in there, if only they had a crankshaft that was solidly reliable.
And the valve gear was good to 15 at least, right? Didn't they test?
That's what they rig tested it, which is a little different because the crankshaft is once you connect the valve gear to a running engine, you've introduced all that boom, boom, boom of
other vibration, every cylinder.
functions.
Every cylinder firing. We tend to think of, oh, it's turning 7,000 RPM and it's this very smooth operation, or 14,000 RPM. But every time the power hits and every time it's coming up against compression, there are all these things that are slightly varying the speed of the rotational speed of the crankshaft, which would be why Yamaha did the 90 degree, the cross plane 4-cylinder in MotoGP, so that to keep 2 cylinders from stopping at the top and the other 2 from stopping at the bottom in a 180, which was causing a variation in crank speed that a rider would ultimately feel in traction at the rear wheel. So there's lots of
not traction
or yes. Not traction. Yes, that is more accurate. Good job. So 15,000 RPM. I guess my question for you then would be, so the original crankshaft was a single piece, and then they're putting rollers that are split over that, and they were having problems with that.
Yep.
Right. So they had a single
then
piece
they
crank.
Had to go to the pressed together crankshaft.
So pressed together means you get a circular bearing, and then your rod has no bolts because you can put it on the shaft and then press
solid rod. Yes.
Solid rod. And you can just put the stuff together as you would on an RD 350 or, any number of those.
Incidentally, the C series R2800 large aircraft radial, I flew in twin engine planes in my youth that had 2800 power, and the crankshaft was made in 3 pieces, and it was assembled by means of curvic couplings, trademark, but basically a radial face spline, only optimized to prevent fatigue failure. So here is this tremendous engine with 18 cylinders all thumping away on 2 crank pins, and the whole thing is assembled out of pieces. The crankshaft was in 3 pieces so that the master rods could be in 1 piece. And a lot of these things were still being worked out in the 1950s. It's interesting to note that the idea of screwing the cylinder liners into the cylinder head as a means of avoiding having to have all those studs and bolts and compressive force on the cylinder in order to keep the head gasket there, sort of like stepping on the cat's tail to keep it from running out the door. Let's just do away with the gasket. Let's screw the cylinder liners into the head. And it was Aurelio Lampredi at Ferrari who first did this in 1951 with Ferrari's 4-cylinder 2-liter engine, which dominated European racing in 52 and 53, something that you can bet Carcano and his men knew all about. So not that they copied, but that the other fellows showed that it could work.
Yeah.
And
well, I wonder about the culture at that time, because you had, Ferrari, and you had all this stuff in the Motor Valley, coming yep. to be. And then you had Guzzi, up in sleepy Lake Como.
Mandela, yeah.
Mandela Delario. And I'm sure they got together and they were at race circuits and all that, but you wonder about the mix of the culture and who's talking to whom and et cetera, how the ideas are spreading around, and where you get a whiff of, the inside look at how that's made, like, a guy at the foundry or, like,
that's
I'd like to swing by and
door.
Yeah, I'd like to swing by.
The back door is a prolific source of information. It's also said that had they continued in 58, that Carcano intended to use a forged 1-piece crankshaft with plain bearings.
Oh, why did they quit? Imagine that. Oh, jeez.
They quit because of the Fiat 500.
Yeah.
Once European auto factories got going on affordable cars, English families were no longer having to put up with an Ariel Square 4 with a wicker sidecar for the trip down to Bognor Regis.
Oh, the sidecars of that era in England, they were so complete. They were like small cars themselves.
Yes.
They were enclosed. They had windows, you like beautiful interiors, velour and velvet, and what a thing it was.
Indeed.
But once the Mini hit, forget it, man.
Yeah. So what happened at the end of 57 is that the Italian industry had made a mass bug out from racing. So after that, only MV was left standing. And that was partly because MV had become a helicopter company. They had
Well,
licensed.
they weren't really selling transportation at that point, right? I
No,
mean, they were building helicopters. They were immune from the vagaries of the market.
the disappearing motorcycle market. Yeah.
Yeah.
So some people have claimed that the Guzzi V-8 had severe handling problems, and Lomas's story has it that Ken Kavanagh, a respected Australian racer, had a thing about the V8 that he was expecting the worst from it at all times. And Lomas was used to doing back-to-back testing. Okay, now with the rear wheel moved back 5 millimeters. Okay, now 10 millimeters. And scientific method. And in this one test, they were trying to stabilize the V8. And he had asked his mechanic, Pomey, to bring some lead sheeting, which I suspect was roofing. And Pomey affixed 20 pounds of this to the front of the frame. And it was more stable. It was better. So then Lomas said, do you have a way to move it forward? Well, yes, we can do that. They moved it to the front fairing stay. And Lomas said it felt sort of heavy at low speeds, but on the racetrack, it was more stable again. So
Well, he had tried another seat to give himself a little more room. That it moved him back on the bike.
Yes, when being a longer-legged fellow, he asked for a longer seat. It made the motorcycle less stable.
Because Guzzi paid attention and moved the weight forward on the motorcycle in doing this, and that everyone was figuring out, as you had with the Manx.
There's a wonderful photo, also from the 50s, showing Jeff Duke on the Gilera with 3 inches of packing between his butt and the seat stop. So that is something that crew chiefs everywhere have 3 inches of packing somewhere in their kit.
A tradition carried on. A tradition carried on today. You always tell the story of Matt Mladen and his crew chief Peter Doyle and
at Willow,
at Willow, stacking them up on there, getting them over the front makes a difference.
And I would see in races, for example, U.S. Grand Prix that used to be at Laguna Seca. Here comes Wayne Rainey. You can see him at a point in turn 11 pull himself all the way forward, and he's holding himself there with his arms as the motorcycle accelerates. This is one of those two-stroke explode off the corner jobs. And this is why people racing those motorcycles had heart rates up to 180, because they were working hard. They were jumping all over the motorcycle, and they still are today. If you watch the videos, you'll see that it is really side horse Olympics with a 300 horsepower engine added. So I thought that it was excellent that Lomas included that about the relationship between stability and weight on the front wheel, because it remains true today.
The heart rate thing reminds me of a conversation I had with a guy many years ago, like a sports physician who was working with riders, and he was instrumenting riders during the rivalry days of Max Biaggi and Valentino Rossi. And you can imagine what I say next is Biaggi was like 200 heart rate. Like you could just, his personality is that, right? Like the keyed up guy. And Rossi was like, 170, like his heart rate was much lower. It was a really interesting conversation. But it's a lot of work.
So what Moto Guzzi needed was time in which to find the right place for the engine, after which they could address the normal handling issues. I think that Lomas said it got the front end to work quite well with it had a short leading link front fork, and which was very much Guzzi's thing in the 1950s. But the end of 57, everything ended for the companies that pulled out, and the V8 became a museum piece. And what a wonderful thing, a wonderful sound, and overarching ambition. We can build a V8 and make it win races. Honda talked about possibly needing to build a V8 for the 250 class, but as it turned out, in that case, the end of the 1967 season, the Japanese companies, with the exception of Yamaha, all pulled out of Grand Prix racing, and there was no more need for it. But
and there was, well, I mean, Honda was focusing on cars at that point, so they were really
yes, they were.
They were putting a lot.
As early as 1954, they were planning a truck plant that they were going to build shortly. So the rule in business is if you're not expanding, you're losing, you're shrinking. And so they just kept adding new balloons and blowing into them as hard as they could, and it worked. Guzzi, Carcano, and his boys were working at just the wrong time. After his employment at Guzzi, Carcano became a yacht designer. He could turn his hand to a variety of work.
Oh, Carlo Pirelli mentioned that in this story, that he liked racing yachts, and he had many refinements to his ships, boats that were quite effective.
Yeah.
But Carlo starts that story about Carcano sitting at the Italian Grand Prix, and he watches the shaft drive 4-cylinder come through and watches the rider struggling, off and on the throttle because of the effect of the shaft drive.
Torque effect, yes.
Torque effect of it, both torquing the motorcycle and the torque effect of the pinion riding up and down on the ring gear at the back, which is why older.
Comical.
Yeah, so if you don't have the 4-bar linkage that was later used on Guzzis and also on BMWs, that the early BMWs, even the street bikes with not very much power, you roll it on and it would stand up, and you'd roll it off and it would squat down. So he watched the bike, the shaft drive bike come through, and they'd had great success with his chain drive 350, and that was, according to Carlo, his basis for saying, like, look at him struggle, and also watching the 4-cylinder come through the same corner and not doing well, like,
Yes.
wobbling through the corner, and yet turning in a smoking fast lap time. And then he watched his riders come through with what was described as perfect form. On his perfect motorcycle, they said, we need a 500 that handles, and that's where the chain drive, that was their experience with the chain drive. And then, V8, you get that, as you pointed out earlier, you get that 4-cylinder width, but you get 8 cylinders of multi awesomeness. And I mean, I love an inline 6, but it would be wide.
Yeah. In a 500 with all those larger cylinders. So the Italian 4-cylinder builders got a bitter lesson from Norton in 1950 and 51. In 1950, the Norton single, ridden by Jeff Duke, nearly took the title, and only episodes of tire chunking prevented him from being world champion in 1950. The Norton had a twin loop frame. It had a broad base for its swing arm. It had smooth acting hydraulic damping front and rear. So the Italians looked at this They looked at the frames they were putting on their 500 four-cylinders with little skinny tubing. Something to consider. And friction dampers that worked like a pair of scissors with a tight joint. That was the standard in 1930. And in this case, Rex McCandless showed them in the new featherbed 1950 chassis that even a week-old 1930s design like the single-cylinder Manx Norton could beat the fours because it got around the track better. So the Italians called what happened next Nortonizing. So the English riders who were hired to ride the fours, first Jeff Duke and many others, including John Surtees, went to Italy with Girling units in their luggage and other helpful things from other engineering traditions. And so the Italians, once they caught up, their four-cylinder bikes were essentially in an impregnable position. But it can take years because, as we know, people are fond of their preconceptions and will defend them even when there is overwhelming evidence that they are a problem. Part of being human. We'd probably be better at marriage as a species if we were able to consider the facts. So it's a grand thing to see this kind of change in our own time. Ducati for years was finishing 6th, 7th, and 8th in MotoGP and couldn't seem to do any better than that. And I think they decided to turn their method on its head, and instead of backing one rider by shaping the machine to suit him, they would build a fleet of motorcycles and put on them the latest graduates from Moto 2 and let them learn to ride what was there. And after several years, Ducati has become dominant. So these changes, not only do they occur, but they take time to mature. So if it's impossible to postpone gratification, it may not be very exciting. But if you look closely, you can see these things happening. And I find it tremendously interesting.
Same. I enjoy the detail refinements that are sometimes hard to detect, certainly in the era. Like, it's to get a good look at a Ducati MotoGP bike with the fairing off is almost impossible.
Yeah.
Right. There were a couple points on the Guzzi V-8 with some wonderful details, like changing the they lengthened the swing arm. I think it was 3 centimeters at one point. They lengthened the swing arm, and they went to a eccentric clamp, and it held the rear wheel more steady.
Yeah.
That helped them. And then I'm always fascinated because I work on motorcycles, and take a drink, folks. Velocets have a single carburetor, my 500. So you just have a cable. You don't have to synchronize anything. You don't have to worry about opening friction. But then there were twins where they would take a single cable from the grip to a barrel-shaped deal under the tank that had 2 cables, and then those would run on the top of the carburetors, and then you're syncing the idle with the screws on the sides of the carburetors, and then you're synchronizing the pickup with the length of the cable. Fiddly business doing that over and over again.
So the slides come up together.
So they come up together, and my method was always to make sure that initial pickup was as perfect as I could make it, and that the ensuing bottom quarter was bang on, because the percentage difference at small throttle openings of that change was significant, and you would get a significant difference in the cylinder. Whereas if you were 3/4, a fraction is such a small percentage of the area that it wasn't nearly as important.
Didn't affect the airflow much.
Yep. And so you would get a very smooth pickup, and you'd get a very smooth cruise that way with small throttle opening. And, these are things on my mind when I look at a picture of a Moto Guzzi V-8 and I say 8 tiny carburetors beautifully stacked up, with their horns crossing in the V. And how the heck do you open all those things exactly at the right time when you want them to open?
Well, this is why the carburetors were their open mouths. You couldn't hear them saying anything, but what you would have heard if they spoke louder was, "Please rack mount us," so that we could be operated by one cable.
They were, but that's what's beautiful about it, is they were operated by a single cable. There's a big arm that goes over one of the banks, and it has linkage, and these cute little hooked, they're almost like rocker followers. They're almost like rocker arms. They are rocker arms, finger followers. And they've got little holes drilled in them. And there's one arm that goes over where the cable connects. And then the linkage is all over top. And it was described as having a very light throttle. Mm-hmm. The Moto Guzzi V-8 with 8, 20, or 22 millimeter Delardo carburetors. They did work on the floats, right? They changed the floats to change the way the engine.
Oh, that was a Triumph, and BSA had a problem here too. When they put GP carburetors on their triples, they tried to have a large float chamber at one side, and they had the same problems that Moto Guzzi did. Moto Guzzi started with one big cylindrical float chamber. It didn't flow enough, so they added a second one. And as Bill Lomas says in his book, depending on whether you were cornering to the right or cornering to the left, you might have it pick up nicely and accelerate, or it might go, did you want something? And so it was begging for 8 tiny float chambers that were tucked into the interstices between all those carburetors. Quite a wonderful intake system.
Yeah, I mean, the concentric idea, the amyl concentric, making the float bowl concentric to the main jet.
Oscar Hedstrom, 1903.
Oh, amazing! So
he did it first in the U.S., and I think that one of the Germans did it first in Europe, and it's an idea that's still with us.
Yeah, because my personal experience is pre-unit Triumph with a monoblock, and the monoblock, the float bowl is offset.
Lumped on one side, yes.
It's a lump on the side of the carburetor, and so they work pretty good. But if you throw it on the side stand, it doesn't like it too much, at least not on my bike.
Yeah.
And depending on which way you're leaning, it would be lean or it could be rich, because the flat height of the fuel was dipping below if you turned it, say, to the right, and it was going up too high. And if the float level's higher, you're getting more fuel per signal.
Yep.
And changing the mixture. And that was the great progress that the concentric brought, because jet, float bowl, lean the bike, and the fuel is in the center of the float, and it stays roughly similar, and you get pretty good running. You can even park your Commando on the side stand if you want to be so audacious, and it might continue to idle. Hard to say.
And the tar isn't soft.
Yes. But yeah, the tiny little matchbox floats on each one of those at the end.
Another point on the Guzzi V-8 is that the normal tire fit was a 275 front and a 300 rear, which is what Yamaha TD1 250s came with in 1965. And it was widely believed in Europe that if you put on bigger tires, that you would slow your motorcycle down. And Carcano was able to show that the little narrow tires were not a handicap on the horizontal singles. and that performance in rain was, of course, much better because the narrower the tire, the more resistant to hydroplaning. So I think it's easy to see the Guzzi V-8 as a kind of tragedy in the Greek sense, that someone boldly launches a program, and for a variety of reasons, it comes a cropper. It doesn't produce results. Oh, boo-hoo. But what was going to happen very shortly, this was 57, by 61, Honda would be winning 250 championships one after another with the same basic notion. Let's put together a bunch of 44 by 41 bore and stroke cylinders and see what we can do with it. So the idea of cylinder multiplication, which was kicked off in a big way by Carcano and his boys, they didn't have the R&D oomph to make it happen, but it happened very soon afterwards. So it was definitely going in the right direction. Those men weren't wrong. They were just underfunded.
Just wishing so much that it had continued to plain bearings.
Yeah. Because
imagine,
then they could have run the engine to any speed they liked.
Think of it. I mean, think of 1964 with a Moto Guzzi V-8 and development time and progress. I mean, it's just what a thing it would have been.
Well, we know that Honda, with their, you could almost say that the NR 500 was a V8 with its pairs of pistons fused into one oval piston.
Yep.
And each cylinder had 8 valves, just as though it were two independent cylinders. And they were able to get that thing to make 136 horsepower at 19,000 RPM at the very end. And it didn't ever win a single Grand Prix point, but Honda were willing to put huge effort into it. 3 different marks of oval piston V4 were built and tested and taken to the races. They did their damnedest. It wasn't going to happen because they had stepped onto the 2-stroke escalator at a point where it was going up too steeply. The 2-strokes could add more power a lot more cheaply than a 4-stroke manufacturer could do it, because in order to add power with a 4-stroke, you have to rev it up more, which means all the usual headaches. So again, bad timing. We need more time. But I think that it's great to listen to the music of those engines, which you can have on recording, or you can get it on the internet and listen to it.
Yeah.
Because there is the song of the future being sent from 1957.
Your time comment made me think of who was that fella who was the Indian tuner? He tuned Indian race engines.
Oh, C.B. Franklin.
No. In recent times, like vintage race, that guy with the H-beam connecting rods and shoot, what is his name? I don't remember his name, but he was Bob Nichols. So Nichols was sort of eight in his 80s, I think.
And when I first started talking to him, he was.
And frantically developing vintage Indian engines.
For the Scout.
Yeah, the Scout. And just, I mean, buried in it and frantic about it. And that's what he said. There isn't enough time. He just wanted to keep doing it. I just, I admire that so much, you know.
At one point, he phoned and he said, "I've done it. I was able to buy a big base bottom end." And the big base was had a sort of crankcase extension to the rear at the bottom, so that when the whirling crankshaft threw off oil, it had some place to go rather than being thrown up into the rear cylinder, which would smoke and foul plugs. And it also provided a place from which the scavenge pump could pick up the used oil from the engine and recirculate it to the tank. Bob Nichols was a Douglas engineer for years and years, and he was in 3 plane crashes during World War II and survived them all. In one case, he had to swim 7 miles to an island that he saw out his side window as the transport plane, with its engines going spot, pop, bang, descended into the Pacific. So he thought, well, I'll give it a try. He said, they came and got me after a few days.
Amazing. So I was thinking back.
Yes?
No, go ahead.
He described being at a casual luncheon one day where everyone there, as he told it, except himself, was a major contributor to American racing, among whom foremost was Leo Goosen, who had, I think, started with Miller in like 1919 and was still designing stuff right to the end of his life. And
Dick O'Brien was like that too.
Yeah. Because what else are you going to do? Sit on the porch facing the sunset with a rug over your knees?
Yeah, I called OB to interview him many years ago, and he was in Florida. And he said, you know, he was legendarily profane, just cussing his punctuation. And he said something along the lines of, "Yeah, I come down here to Florida to rest up, and da, 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 da. And they just send me these goddamn NASCAR heads."
Yeah,
it was awesome.
Yep.
Very cool. I was just thinking. I was trying to think of the connection of Moto Guzzi's inline 4, and it was the guy. It was an engineer called Giannini.
Yes, Giannini went way back.
He was one of the Rondine, or Rondine, yes, as we'd also say. He was one of the Rondine guys who did the inline 4. We did a podcast on that, and that Rondine became the Gilera, and he was he had helped design that, or did design that longitudinal inline 4.
Yes, that's right. I forgot that.
With the shaft drive, and that they threw away, and but again, it's that culture, you know, the Italian engineering racing culture, and everybody's mixing around and trading jobs, and I'm going over here to do this, and I have these ideas. And
well, the V8 came into being in just a few months. And they had the idea, they laid out how they wanted it to be, and they just built it. No committees. The big cheese, Perotti, said, let's do it. And so soon he could hear it run. And that is why outfits like Lockheed had to create things such as the Skunk Works, which had carefully been designed to remove social friction. Committee meetings, memos, they just put everyone together, and they found that taking engineers off of a project made it move forward faster. So I think probably Carcano and his boys got the thing running faster than the modern companies would be able to do, because they definitely have this internal friction. What they didn't have was a test team and an R&D operation backing it up. And what are those 12 boxes? Oh, those engines are obsolete. The good stuff's already on the truck. Oh, good. Yep. Because it takes a lot of hardware to support a racing effort. Oh, this engine is wrecked. Put in another one. 20 minutes later, you're running in practice again. Now, one of the problems that they had repeatedly with the V8 was big end failure. So they decided to increase oil flow by putting oil into both ends of the crankshaft. End feed is a standard method of oiling Formula One and other kinds of race engines. Because in that case, centrifugal force works for you. The oil enters at the center and flings itself outward. Whereas if you're trying to force oil into a bearing from the oil supply into a main bearing by grooving the bearing shell so the oil holes are always under pressure, forcing oil into the crankshaft so that a drilling can carry it to the next crank pin. Centrifugal force is saying, no way. And I put centrifugal force in quotes because, of course, your high school physics prof will explain to you that centrifugal force does not exist. What's happening is simply that the inertia of what is being forced into a circle, the inertia wants it to just keep going in a straight line. So double end oil feeding, cylinders screwed into the cylinder head, narrow valve angle, one after another, lovely modern innovations that are with us to this day did appear on the Guzzi V8. And there was the reason for these failures, which everyone has listed, and for the fact that it never won a Grand Prix, is that it had to, they basically, like a club racer, they took it to the track to work on it. And that won't work at the top level. You've got to be confident as a result of many testing that we have ignition. The thing is going to lift off, and soon it'll be sparkling in the sky downrange.
But still, does anybody go to bed early at the racetrack? I mean, honestly, no. I mean, you could come in with all the confidence in the world and you're still panicked, aren't you? I mean,
well, of course, they try to avoid that. That's why Bud Axlin, who worked with Kenny all those years, developing cylinders and pipes and so forth, said, I don't mind doing an all-nighter. He said, they're part of racing. But he said, I sure don't want to live there.
yeah. Yeah, I have to say, racing in Arma last fall on that BMW Dan Mays that I borrowed, R75/5, it had, I think he had raced it for 12 years. So and it was previously raced by a friend of his and he bought it from him and it was just developed, and it also isn't, it wasn't trying to make 100 horsepower. It made 70 really nice horsepower and it'll do that for a long time. It's not going to scatter and it's competitive and repeatable. And it was such a repeatable motorcycle. It did everything the same every time I rode it. I didn't change any suspension damping. I didn't change carburetor adjustments, nothing. And so in that sense, it was very nice to show up with a developed motorcycle, even though it wasn't making 110 horsepower or anything like that. It's not Grand Prix, it's Arma, it's different. But it's good to be it's good to be prepared.
Sit on it and go.
What a magnificent, yes.
There can be so many steps to reach that point. And Guzzi didn't have the organization, the funding, or the time. But it was a fabulous effort. And it did bear fruit, just not the fruit they'd hoped for.
Yeah. Double overhead cam, 90-degree, liquid cooled, V8, narrow valve angle, pushed up forward in the frame. They lengthened the swing arm.
Yep.
They pushed the rider forward. They had different fairings. They had problems with the dolphin fairing versus the full fairing. But I don't know. I guess not. I don't think of it as a failure. You know, you do want to build a race bike and win races, but in the same way, as you mentioned with the Honda, there's a magnificent exploration there. And I think, don't you think with a little more development, they would have done it?
In 58, for sure.
Oh, yeah.
Well, the same basic thing happened with TZ750, which we've also spoken about in these podcasts. Kell Carruthers was asked to go to Japan and test ride the thing before they committed it for the 1974 Daytona. And when he rode it, it weaved. He couldn't reach top speed because it began to at 2 or 3 cycles per second. So what did they do? They lengthened the swing arm. And that's the way they stabilized it. And Agostini rode the thing at Daytona. The exhaust pipes all blew apart. He finished the race in first place. Kenny Roberts was second, having broken a cylinder bolt. I should call it a nut. Those bolts, those nuts were cracking on quite a few TZ750s, and there was an immediate warranty on it. So the same kinds of
Countermeasure
problems
parts
are encountered all the way through history of the motorcycle.
Yep. Well, thanks for listening, folks. That's the Moto Guzzi V-8. Thanks again to our sponsor, Octane Lending. I really enjoyed this one because I've always loved the Guzzi V-8, and it was really fun to read up on it and explore, and then to get, of course, all of your research as well to put this together. It's just what a wonderful thing it was.
It's unfortunate that during this podcast we didn't have the sound of the V8 rising and falling in the background and turning to see what it could be.
Well, we'll leave something to the rest of the internet to provide.
Yep.
I'm just glad to throw a couple pictures. We have some great photographs, original press photos from Moto Guzzi of the bare engine and some other stuff that will get slid into the production. Thanks for listening, folks. We have a full complement of back podcasts, more than 60 episodes. You can listen on the Rondine TZ750, how to dissipate heat, disc brakes, how suspension damping works. It's hopefully infinite.
Yes.
So far, so good.
Yep.
Thanks for listening.